Does your company run a dedicated Kubernetes cluster per customer, deployed across AWS, GCP, and Azure? And some of those are hosted in your own account, while some of them are hosted in the customer's account, usually for isolation or security reasons. And if you are relying on the native cloud provider's observability for monitoring and debugging, I'm sure you're running into one of these challenges. First, if there is a problem and you want to see how the metrics look across cloud providers, there is no great view for you to do that today. So that's like a considerable challenge. You need to look at different consoles, you need to jump between projects and mentally compare these clusters. The second problem is, even if you find a way to get all the telemetry into a single account, let's say from multiple GCP projects into a single GCP project, these native solutions aren't built for these cross-project, cross-account visibility. Over a period of time, when there is meaningful scale, the queries start to slow down. You will probably start experiencing timeouts when you are loading these dashboards. There is a significant degradation at meaningful scale. And finally, coming to the third problem, you have three different cloud providers building the solution differently. You will find that the metric names are different in each of these platforms. The engineers need to understand what these metric names are in each platform. You might have certain panels in GCP that you really like that are missing in EKS, and vice versa. There is a considerable learning curve to this for every engineer to understand how they can navigate the platform, how they can extract the necessary metrics and the necessary information from each of these platforms. You don't want to be stuck navigating and finding the telemetry that you need to debug problems. Let me show you how you could get full Kubernetes observability. Metrics, logs, Kubernetes events, service graph, anomaly detection across all your clusters, across all your cloud providers with just 2 Helm commands while meeting your security and compliance requirements. So once you log into your Oodle platform, this is the Kubernetes overview page. Right now, we already have an EKS cluster integrated, so it's running in our demo AWS account. Now let's see how we can integrate with a new Kubernetes cluster. So go to the integrations page and click on the Kubernetes tile. This page shows all the instructions you need to get started. Let's start with a name for our cluster. Since we're going to integrate with a GK cluster, let's call this GK1. This is not an autopilot cluster, so we'll go with the option no. The fourth step mentions all the different telemetry signals that we collect. By default, it is metrics, logs, eBPF-powered APM, and then Kubernetes events. I just want to call out over here that all the agents that we run in your cluster are open source. There are no proprietary agents that are deployed. So in the next step, let's verify we are pointing to the cluster we're going to integrate with. Great. Next, let's select the API key I want to use for this integration. Kate's demo is an API key I generated earlier for this demo. So the sixth step is to create a secret for the Oodle API key. Great. Now that's done. Using the options you have selected above, the Helm values is automatically generated. Let's copy this file. And finally, we just need to run the Helm command in step 8. Basically, in this Helm command, it uses the values file that we generated earlier, and it installs different components to collect various telemetry. Give it a few minutes while it installs all of these components. Great. Now all of them are installed. We can switch back to the Oodle platform. So here you can see that we have started receiving telemetry data for the GK1 cluster. In this overview page, you get a high-level summary of all the resources across all your clusters. You can see that there are 2 clusters that we have integrated right now. One is from EKS and one is from GKE. There are a total number of 3 nodes across all these clusters, the number of namespaces, total number of pods, total number of containers. You can also quickly see what is the total CPU utilization, memory utilization. There are right now 8 anomalies that Oodle has detected in these clusters, and a quick summary of the pod status across all these clusters. This is the same interface that you're going to see for all the cloud providers. So even if you're integrating GKE clusters or EKS clusters, the interface is the same. From here, you can easily drill down into a particular cluster and see what's happening in that cluster. So we have these two clusters, play, which is the case cluster, and GKE. Let's look more into the play cluster. So there are two nodes. To click on a node and they can really quick see what are the infrastructure metrics in this host, the CPU, the memory. You can also easily jump and navigate via the namespace. So if you click on the OpenTelemetry demo in this case, you can see what are all the different workloads that are running. You can quickly look at what are all the pods running in this cluster. Let's say I want to check one of these out. So email service pod, what is the CPU and memory usage per container, per pod, and also what is the usage in the node in which these pods are running. You can jump to see what is the workload, which is the deployment in this case, the email deployment look like, what are the logs in the service, and also quickly look at what the Kubernetes events related to the service are. Similarly, it's really easy to navigate to any resource across all your clusters and investigate them further. In addition to navigating and looking at each of your resources, Oodle also offers this optimizer page, which essentially tells you how you can optimize your cluster. So what we do is we look at your 30-day peak usage for memory and CPU and compare it with the request and limit values you have set in the Kubernetes configuration, and then tell you that, okay, how much can you reclaim? So how much have you over provisioned or under provisioned your cluster? For example, in this case for the front-end service, the 30-day peak is 139.6 MB, but we have provisioned for 250 MB. So there is some scope of improvement. The optimizer page can really help you identify where to optimize on to save you on costs. You can also use Oodle's default out-of-the-box Kubernetes dashboards to look at metrics and telemetry across your clusters. So in this global dashboard, you can see that this is showing data aggregated over the two clusters that we have configured. So let's say you have hundreds or thousands of clusters. This dashboard will essentially show you various stats at a global level across all your clusters. Or if you wanted to investigate a certain issue, you could narrow down to a single cluster or a set of customer-specific clusters. This is a quick way to get out of the box visibility into telemetry data aggregated across all of your clusters, across all cloud providers. So here's the thing. The modern interface for any product isn't querying data with PromQL or Lucene. It is just asking questions in plain English and getting directly to the answers you need. Root cause analysis and detection has completely changed in the AI era. With Oodle, you can ask questions in plain English and debug your problems. For example, let's say you want to understand what are all the anomalies in your cluster. So you can just ask that directly. And let's say for the play cluster. So you can just sit back and let Oodle do the debugging on your behalf. Behind the scenes, Oodle is going to look through all the necessary telemetry data from your cluster. It has access to a large set of tools to narrow down what the problem is and represent or show to you what is happening behind the scenes in your cluster. So here we can already see that Oodle has started understanding what's happening in your cluster. It was using the query anomalies tool and is surfacing a bunch of different anomalies that are present in this cluster. For example, the containers have been restarting for recommendation service. This is something that needs to be looked at, probably increase the memory for this service. These are all the inbound communication errors between the client and server. And you can also see that Oodle has identified what the error rate is. Similarly, another set of high API error rate services. So really quickly, when a customer reports an issue or proactively if you're investigating a problem, you can talk to Oodle, ask what your problems are in plain English, and directly get to the root cause.